Let's talk about the 6 trig functions. So we know that there is sine, cosine, and tangent. And then there's also cosecant, secant, and cotangent. Now, these don't work just on their own. They're a function of an angle. So for instance, if one of our angles in a right triangle is labeled as theta, and it's very important where it is, it's one of the acute angles, not the right angle. But we would say the sine of theta or the cosine of theta, the tangent of theta. All of these, you're taking the trig function of the angle. So the question is, what do each of these equal? And so when we're looking at this, it really strictly depends on where your theta is. So if your theta is in this angle versus this angle, your answers for each of these are going to be different. So based on where your theta is, you need to label your sides. And we're going to label the sides that are opposite. So the side that is opposite theta, directly across from it, is side B in this case. You want to label the hypotenuse, which is always across from the right angle. So side C is your hypotenuse. And then the side that's adjacent to the angle is basically the side that is left over but is touching that angle. So this angle right here, this side is touching, this is the adjacent side. You've probably heard SO, CA, TOA, and this helps us to write the ratios for these 3 trig functions, and then we'll come back and look at these as well. So let's talk about the sine of theta. In this case, the sine of theta, so S, so the sine is opposite over hypotenuse. So from theta, the opposite was B and the hypotenuse was C. So this would equal B over C. The cosine of theta, again, thinking about SO, CA, TOA, cosine is adjacent over hypotenuse. So if theta is here, the adjacent side is A, and the hypotenuse is C. So we would have A over C. The tangent of theta, with TOA, tangent is opposite over adjacent, so B over A. The other 3 trig functions, you have to remember what they are, and they are basically the reciprocal functions of your sine, cosine, and tangent. So cosecant of theta is the same thing as 1 over the sine of theta, or in other words, it is the reciprocal of sine. So if the sine of theta is B over C, then its reciprocal for cosecant, if you take B over C and you flip-flop these, you would have C over B. So the cosecant of theta is C over B, or in other words, the hypotenuse, right? This is the hypotenuse over the opposite for cosecant. Secant is the reciprocal of cosine, so it's 1 over cosine of theta. Well, if cosine of theta is adjacent over hypotenuse, then that means secant is hypotenuse over adjacent. And that would be C over A. And again, we could have just said, okay, if cosine is A over C, then secant is C over A. And then cotangent is the reciprocal of tangent, so 1 over the tangent of theta. Or if tangent is B over A, then that means that cotangent is A over B. And if tangent is opposite over adjacent, then cotangent is adjacent over opposite.